Lesson 89. In this lesson, we are going to look at how Maclaurin series can be useful to help us to come up with the particular solutions of differential equations. So let's recall first order differential equations. They take on the form of dy by dx as a function of f of x and y, and with a condition or initial condition of y of 0 equals to y naught. And we're looking for a function in terms of y and x that when I take the derivative of that function, it will give me the derivative given to me. Okay, so that's the whole purpose of solving differential equations. And given that the necessary derivatives exist, we can actually use the Maclaurin series to help us. Provided that the necessary derivatives exist, a particular solution in the form of y of x can actually be expressed using a Maclaurin series. So let's see how this works using example 1. We will be using the first 3 non-zero terms of the Maclaurin series to approximate the solution of y prime equals to x minus 4xy if y of 0 is equal to 1. We know that the terms in the Maclaurin series include y of 0, y prime of 0, y double prime of 0, and so on and so forth. And what is given in front of us is the first derivative y prime, correct? So now I'm going to put it in this row so that once I list out y prime, I can also calculate y prime at 0. And we also know that y of 0, the initial condition, is equal to 1. So very similar to how we usually work out a Maclaurin series. We're going to use this chart just to, make it work more organized. You don't really need a chart. Okay? So here we know that y prime is x minus 4xy. So that y of 0 is going to be x is 0 minus 4 times 0. The y value is 1 given above, which is 0. Okay? So now y double prime. We're going to take the derivative of y prime. So dx by dx, 1. Minus 4xy, which is product rule. So we're going to have 4 times 1 times y, 4y, and then plus 4x times the derivative of y, but there is a minus in front of this term, so this becomes negative 4x y prime. I'm going to use y prime instead of dy by dx to save myself from keep writing those d over dx. Okay? So let's evaluate y double prime of 0 is 1 minus y value is 1. So 4 times 1 minus 4 times 0. Y prime we found above is 0. So this is 1 minus 4, which is negative 3. Okay? Then we have y triple prime equals. First term is 0 minus 4y becomes now negative 4y prime as a derivative. And then we have to take the derivative of negative 4xy prime. So here we go. Negative 4x becomes negative 4 times y prime minus 4x. Y prime's derivative is y double prime. Simplifying, I have negative 8y prime minus 4xy double prime. So what is y triple prime at 0? I have negative 8 times y prime is 0 minus 4 times x, which is 0. Y double prime was negative 3, but this is also 0. So backtrack a little bit. How many terms in the actual Maclaurin series have we found so far? We have found, okay, this is the first non-zero term. And then this term will go away because it's 0. So now we only have 2 terms in the Maclaurin series. which means that we have to continue to look for the fourth derivative of y. So here, okay, so what do we have here? I'm going to use the negative 8y prime to start. So I know negative 8, the derivative of y prime is y double prime, minus 4xy double prime. So again, product rule again. Negative 4 y double prime, negative 4x y triple prime, right? And so this is negative 12 y double prime minus 4x y triple prime. And then at 0, this fourth derivative is negative 12 times negative 3 minus 4 times 0 times 0. This is 36. Okay. So with this work, we can now write the Maclaurin series. Okay. So what does it look like? Y, the function y is equal to, first term is 1 plus 0 in the x term, and then the next one is negative 3 over 2 factorial x squared. The next term is 0, and then plus 36. So this is the fourth x to the power 4 term. Okay, which gives us, when we simplify this, 1 minus 3 over 2 x squared plus 36 over 24, so 3 over 2 x to the power of 4 minus dot dot dot. And this is the particular solution of to the differential equation that we got. Okay. Here is example 2. Find Maclaurin series to approximate to solution of dy by dx equals to 2y plus 3e to the power of x, and the initial condition of y of 0 equals to 0. Use its first 4 terms to approximate the value of y to 4 decimal places when x is equal to 0.2. Okay. So here, we know that the first derivative is given by 2y plus 3e to the power of x. And the initial condition is y of 0 equals to 0. Okay? So what is y prime at 0? It is 2 times 0 plus 3e to the power of 0. So 0 plus 3 then. So 3. We need the second derivative. 2y now becomes 2y prime plus 3e to the power of x still. Y double prime at 0, I have 2 times 3 plus 3e to the power of 0. So this is 6 plus 3, 9. Y triple prime is now 2y double prime plus 3e to the x. And so y triple prime at 0 is 2 times 9 plus 3e to the 0. So 9 times 2 is 18 plus 3 is 21. And lastly, because we need 4 terms, and we have 3 non-zero terms so far. Okay, so this is now 2y triple plus 3e to the x. It's almost like a constant there. So y 4 0 2 times 21 plus 3e to the 0. This is 42 plus 3, 45. Okay. So as a Maclaurin series, we have y equals to 0 plus 3 over 1 factorial x plus 9 over 2 factorial x squared plus 21 over 3 factorial x cubed and plus 45 over 4 factorial x to the power of 4. Okay, and so we can simplify it, or if you want to do the substitution and simplify at the same time, that's all right as well. So what do we have here? So 3x, 9 over 2, x squared, 21, 3, so plus 7 over 2, x cubed, plus 45 divided by 3, 15. So 15 over 4 times 2 is 8, x4, and of course, dot, 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 dot. Okay? So now when x is equal to 0.2, we can substitute that into the Maclaurin series. So 3 times 0.2 plus 9 over 2 times 0.2 squared plus 7 over 2 times 0.2 cubed plus 15 over 8 x to the okay, 0.2 to the power 4 plus dot dot dot, and this works out to approximately 0.8110, just like that. Okay. If you would like to try this question by yourself first as practice, you can now pause the video, resume it to check your answers. So here's the solution to example 3. Find the Maclaurin series to approximate the solution of dy by dx equals to 3x plus y squared. If y of 0 is equal to 1, find the value of y of 0.1 to 4 decimal places. So the steps would be very similar to what you did in example 2. I'm going to start by writing down the initial condition. I'm going to start by writing down the initial condition of y of 0 equals to 1, and also the first derivative as 3x plus y squared. So I know that y prime at 0 is going to be 3 times 0 plus 1 squared, okay, which is 1. Now y double prime, I have derivative of 3x, so 3 plus derivative of y squared, 2y, y prime. Okay, so y double prime at 0 is equal to 3 plus 2 times y, which is 1, times y prime, which is also 1. This is 5. Y triple prime is 0 plus. Now I have 2y times y prime. This is still a product, right? Because it's a product of 2y and y prime. I still need to use product rule and also apply implicit differentiation very, very carefully. So first, derivative of 2y prime times y prime plus 2y stays. I need the derivative of y prime, which is y double prime. Okay, this is 2y prime squared plus 2y y double prime. Evaluating at 0, I have 2 times y prime is 1 squared plus 2 times y, which is 1, times y double prime, which is 5. So I have 2 plus 10, which is 12. Okay. Next, we've got the fourth derivative. So now let's be careful here. I have 2 of y prime squared, so I can use the power rule for y prime times the derivative of y prime, which is the y double prime. Okay, and then plus product rule again, 2y times y double prime. So the first thing is 2y, it becomes 2 times y prime. Stick back that y double prime plus 2y stays the same. The derivative of y double is y triple. Simplify this. I have the first two terms are like terms. 6y prime times y double prime plus 2y, y triple. Okay? So now I have y fourth derivative at 0. 6 times y prime, 1. Y double prime, 5. Plus 2y was 1. And y triple was 12. So here we have 30 plus 24, which is 54. Okay? Let's write out the Maclaurin series. Y is 1 plus 1 over 1 factorial x plus 5 over 2 factorial x squared plus 12 over 3 factorial x cubed plus 54 over 4 factorial x to the fourth plus dot dot dot. Let's simplify. 1 plus x plus 5 over 2 x squared plus 3 times 2 is 6, so 2x cubed plus 54 over 4 factorial. So 54 divided by 2 is 27, divided by 3 is 9, 9 over 4. X to the power of 4 plus dot dot dot. Last but not least, I need to evaluate this at y equals to 0.1. So 1 plus 0.1 plus 5 over 2, 0.1 squared plus 2 times 0.1 cubed plus 9 over 4 times 0.1 to the power of 4. Let's see what my calculator tells me. 1.1272 in 4 decimal places. Okay, that's it.